Lesson 5.2, Evaluate and Graph Polynomial Functions. We've graphed linear and quadratic functions, but by the end of this lesson we'll expand to our polynomial functions. Before we graph, however, we need to cover a few things, and I've included this chart to remind you of some basics from Algebra 1. We're asked to do 4 things, and we're given the following functions. So we're looking at number 1, and we're deciding, is it a polynomial function? And the answer to that is yes. We know polynomials are a sum of monomials. Then we have to write it in standard form, which means the terms must be written in descending order. So that would be f of x equals negative 2x plus 13. That's standard form. It's linear with the highest degree being 1. And the last thing we're asked to do is identify the leading coefficient, and the leading coefficient is negative 2. All right, so I would pause the video and give the next 3 a try. All right, the second example is not a polynomial function because there's an exponent that is not a whole number, and that would be this negative 3. I started number 3. Yes, it's a polynomial function. I rewrote it in standard form. Now we need to identify the degree and the type. So it's the degree of 4, so that makes it a quartic. And our leading coefficient is 6. Our final example on this slide, number 4. Number 4 also is not a polynomial function because of this 5 raised to the power of x. It does not have a variable base and an exponent that's a whole number. The exponent here is a variable. Evaluate by direct substitution simply means subbing in the given value. So I rewrote the function. Whoops, you don't want to have an x there. We're going to put a 4. So in each one of these parentheses, we'll include a 4. So go ahead, pause the video, and finish the calculations. All right, once you did all your multiplying, adding, subtracting, you should have concluded that the answer was 9. So this was direct substitution, and you can see that now we're going to take a look at synthetic substitution. All right, so on the outside, we're going to put our x value, which is 3, and then on the inside, we're going to put our coefficients in descending order. So that would be 2, negative 5, 0, negative 4, 8. And the reason we have a 0 is because our x squared value is absent. There's not an x squared, so we're going to include a 0. To begin, we bring down the leading coefficient, which was 2, then multiply it by the x value. So 3 times 2 is 6, and we write the 6 beneath the second coefficient. Then we add those two. 1. 3 times 1 is 3. We add 0 and 3. 3 times 3 is 9. Negative 4 and 9 is 5. 3 times 5 is 15. 8 plus 15 is 23. If we had simply evaluated using direct substitution, you would also get f of 3 equals 23. And you're welcome to try that if you'd like. We're going to apply synthetic substitution to this first function that we did to prove, hopefully, that we still get the answer of 9. So I put my x value to the left, then we'll put our coefficients, so 1, -5, 6, and 1. Then we say, oh, first we have to bring down the 1. 4 times 1 is 4. -5 and 4 is -1. 4 times -1 is -4. 6 and -4 is 2. 4 times 2 is 8. 1 plus 8 is 9. That is the same answer we got when we used direct substitution. So G of 4 equals 9. On video 5.2b, we'll actually graph the polynomial functions.